Hi everyone. So today the topic of our discussion is a very important and a basic concept of conservation of linear momentum. So in this particular interaction, we are going to discuss some advanced level problems and multiple methods for doing the same problems based on this topic, right? So before going to the discussion of the problems, let us first try to recollect that what was this conservation of linear momentum exactly, right? So according to this principle, if the external force acting on the system is zero, which means there is no external force acting on the system, then in that case, the linear momentum of the system will remain constant or conserved, which means you can simply say that whatever finally you are going to get the linear momentum of the system, that has to be equal to the initial momentum of the system. So whenever we say that the final physical vector quantity will be equal to the initial vector physical quantity, that is the linear momentum, which means they should be equal in terms of magnitude as well as in terms of direction, right? So it is a very fundamental thing. Fine, but we have already proven it earlier, right? So no need to prove it again and again, right? We already know that. But yes, while implementing this fundamental concept, we must be making note of two important things, which means there are two fundamental questions one should be asked himself or herself before implementing this principle, right? So what are these two things? The first one is, see, whenever we are saying that external force acting on the system, so one must think what should be the choice of system. The system should be chosen in such a way that maximum number of forces, or you can simply say all the forces will become an internal factor. All the forces will become internal so that there will be no external force acting on the system. And only in such case, when there is no external force acting on the system, then only the linear momentum of the system can be conserved. Which means the first thing you should be make note of is choice of system. Choice of system. The system should be chosen wisely, right? And the second thing is choice of frame of reference. Choice of frame of reference. Now what is that, sir? We have already applied choice of frame of reference, FOR. We have already applied this conservation of linear momentum numerous times since class 9th, right? But we never thought of this frame of reference. Now why that is so important, right? See, whenever you are saying that the final momentum of the system will be equal to initial momentum of system, there are two mistakes which can be there, right? The first thing is, while writing the final and initial momentum of the system, you are standing at two different places, which means you as an observer are having two different states of motion while writing the initial and final momentum separately. This must not be the case, which means while writing the initial and final momentum of the system, one should be consistent, one should be having a fixed frame of reference. So this frame of reference must be fixed. You must be consistent with that frame of reference. Not only this, not only the case of initial and final. See, whenever you are talking about a system, a particular system, we already know that a given system will be comprising of many small bodies or parts, right? So while writing the momentum of the system, we must be writing the momentum of the individual objects. Now, when we are writing the individual linear momentums, then also our frame of reference must be fixed, which means we need to observe all the individual particles and we should write their linear momenta while standing at one particular position only, or you can say with respect to only one frame of reference. Now let us analyze or let us understand that why these two important factors are to be taken care of. We are going to discuss one small problem based on this, right? Problem number one. Initially, system is at rest. The examiner is telling you that initially system is at rest. See, whenever we say that system is at rest, I'm not saying that velocity of center of mass will be equal to 0 and there can be individual particles, few of them can be moving in the positive direction, the rest of them can move in the negative direction, and they will nullify the velocity of center of mass. No. Whenever I say that system is at rest, which means velocity of center of mass is by default 0, rather individual particles, not even a single particle of the system is actually moving, which means each and every particle of the system must be at rest. The meaning of system is at rest is each and every particle of the system must be at rest. Fine. So initially system is at rest. You need to find the recoil velocity. You need to find the recoil velocity of the plank when man starts walking over it. There is a man standing over the plank which was initially at rest, and now the man starts walking over the plank. So there will be a recoil velocity attained by the plank. You need to determine it. Let us try to understand the situation diagrammatically. It is already mentioned in the problem. Now there is a smooth horizontal surface. There is a smooth horizontal surface over which a plank of mass capital M is kept. Plank of mass capital M is kept initially at rest, and a man is standing over one side of the plank, and the man is having a mass m0. It was also initially at rest. Now the man starts walking over the plank with a velocity u, but this velocity u is given with respect to plank, which means if plank is considered as an observer, then according to the plank, the man will be walking over the plank in the forward direction with a velocity u. Got the point? And you need to determine the recoil velocity of the plank. Got it? Now, we are going to solve this problem by applying the simple principle of conservation of linear momentum. But before the application of this fundamental principle, we must be thinking the very first part, what should be the choice of our system? Now here, the choice of system or the system must contain man having mass m0 plus plank having mass capital M. Now why that is so, sir? Why that is required? That is required due to a very, very basic reason. See, if the man wants to walk over the plank, can I say the contact surface of man and plank will be smooth? No, obviously not. Because on a smooth surface, even if we try walking, can we walk further? Can we walk forward? No, because there is no friction in order to support our motion. One must need, we as humans, if we want to walk forward, definitely we want friction in order to support our motion. Without friction on a grease surface, on a smooth surface, we cannot walk, we cannot change our position. Fine. So, understanding this situation, can I say that let us maintain some gap in between the plank and the man in order to have a better understanding of the topic. So if the man wants to move forward with a velocity u, anyways with respect to plank or with respect to ground, it hardly matters. What will be the direction of friction? The first thing is the contact surface must be rough. The contact surface must be rough. Let's say the coming friction force will be Fr. Now what should be the direction of friction acting on the feet of this man? So if we want to move forward, the friction is going to support our motion, which means definitely the friction will be acting in the forward direction. Fine. And where will be the direction of friction acting on the plank? The direction of friction will be in the backwards direction. Because of this friction, due to this direction of friction, the plank is going to attain a velocity in the left direction, which means backward, or you can say this left direction. Fine. But see, if we are going to take man as a system, can we conserve its momentum? No, because this friction is going to behave as an external force. If we are going to take plank as a system, can we conserve its momentum? Again, no, because this friction is again going to behave as external force and it is going to change the state of motion of the plank in the backward direction, which is actually happening. Fine. But yes, if we take man plus Planck as a system, then in that case, the friction force coming into the picture will become an internal force. That is going to become an internal force. This will be an internal one. So what is the external force acting on the man plus Planck system in the horizontal direction? There is nothing. Which means, can we say external force acting on the system, the man plus Planck system in the horizontal direction, that is 0. There is no external force acting on the system. In that case, we can simply say that momentum of the man plus Planck system in the horizontal direction is going to be constant. It will be constant. Fine. And if it is constant, can we also write final momentum of the system in the horizontal direction? It must be a vector quantity, right? That has to be equal to initial momentum of the system in horizontal direction. But what is the initial momentum of the system? It is 0. Why? Because in the problem, the very first statement is initially the system is at rest. And if the system is at rest, can we say the initial momentum is going to become 0? It will be definitely 0. So if initial momentum is 0, the final momentum must be equal to 0. So what will be the momentum statement? Can we say mass of man, that is m naught, into velocity of man with respect to ground plus mass of Planck, capital M, into velocity of Planck with respect to ground. These are the final velocities, and that is equal to initial momentum, that is nothing but equal to 0. Fine. Do we know the velocity of man with respect to ground? No, we don't know, as the velocity of man is provided with respect to Planck and not with respect to ground. Similarly, do we know the velocity of Planck with respect to ground? No, we don't know. Rather, we need to determine it. That you need to determine the recoil velocity. It is quite understood that recoil velocity is to be obtained with what frame of reference? Our frame of reference must be ground. So the second thing is, we need to choose our frame of reference for this statement. That should be ground. And we need to be consistent about it. Which means while solving this particular problem, we are not going to change our frame of reference. Is that understood? Right. So let's say that velocity of Planck with respect to ground is minus v naught. Now why there is a negative sign? Why there is minus sign? Because in class we are taking the convention that forward direction will be positive, backward direction will be negative, or you can say left will be negative. So that's quite understood by this free body diagram of man plus Planck system in the horizontal sense. The direction of velocity attained by the Planck must be towards the left, right? So let us say that it is v naught. Understood? Which means velocity of Planck with respect to ground for this statement will be minus v naught. Then can we write according to relative velocity that velocity of man with respect to ground can be analyzed as velocity of man with respect to Planck plus velocity of Planck with respect to ground. In this way we can obtain it, right? So what is the velocity of man with respect to Planck? Sir, it should be plus u. Why plus? Because it is moving in the forward direction. Right? So we are going to consider this direction and this speed. So what will be velocity? It is plus u. Plus, what is velocity of Planck with respect to ground? Minus v naught. So what is that? U minus v naught. So I'm highlighting this equation. According to this equation, can we say m naught into velocity of man with respect to ground, that is u minus v naught, plus capital M into minus v naught, that must be equal to 0, initial momentum. What is our motto? What we need to determine? Do remember it, right? We need to determine the value of v naught. Then in that case, can we simplify it this way? M naught u minus m naught v naught minus mv naught, that must be equal to 0. So you can shift these v naught terms over that side, so they both of them will become positive. So you will get the value of v naught as m naught u over m naught plus capital M. M naught u over m naught plus capital M, and velocity of plank with respect to ground, that will be equal to minus v naught. So that will be equal to minus of m naught u over m naught plus capital M. Is it fine? Easy problem? So it seems to be a very simple problem based on conservation of linear momentum, but there can be mistakes if we don't take care of two things. The first thing should be choice of system, right? And the second thing is we need to be consistent regarding the choice of frame of reference as well, right? The story is not yet completed. As I have already told you many times that, can you say that this is a two-particle system? Right? Man plus Planck. And I have already told you numerous times that this two-particle system is one of the very common and important systems in physics as far as 11th and 12th grade are considered. Fine. So I'm gonna give you a very simple and analytical shortcut for this. And every time I tell you that there is nothing like shortcut, everything is a generalized solution, and with every generalized solution we must be remembering the constraints associated with that particular solution. So what is that constraint? The shortcut is applicable only for two-particle system, first thing. That too when this two-particle system is initially at rest. This two-particle system is initially at rest. Fine. So what we can say, see here, the first thing which we can say is that initially if it has rest, the system is at rest, which means both the particles of the two-particle system must be at individual rest. Now one start moving over the other with a certain relative velocity, let's call it u relative. Then in that case, absolutely one will be moving in forward direction, then the other will be moving in backward direction. Absolutely one will be moving in upward direction, the other will be moving in downward direction. Absolutely if one is moving towards u, then the other must be moving away from u so as to nullify the final momentum of the system, same as that of initial one. Initially system was at rest, so the linear momentum will also be equal to 0, right? So here can we say that velocity of one object with respect to ground finally in magnitude terms, that will be given by, if you want to write the velocity of the first object, then in numerator the mass of the second object will be coming, which means velocity of one with respect to ground, that will be equal to mass of the second one, mass of the other one, m2 into u relative over m1 plus m2. And in similar fashion, velocity of 2 with respect to ground will be given by the magnitude 1. m1, the other mass, velocity of second will be equal to the other mass, m1 into u relative over m1 plus m2. m1 plus m2. Is it fine? The shortcut? Another thing is, if initially the two-particle system is at rest and one starts moving towards forward direction, the other must be moving in the opposite sense, which means the direction of velocity of one with respect to ground, not necessarily ground, with respect to any other frame of reference, its direction, the direction, which means unit vector, that will be negative of velocity of second with respect to any other frame of reference. So that is direction, unit vector. Hope you'll remember it, because the two-particle system is one of the most common and important systems in physics. So you are going to remember it, right, as a shortcut. Right. Now let us consider second problem. This time initially the system is at rest, and again find the recoil velocity of the plank when both men start walking over it. Now what is the situation? Again, that's a smooth horizontal surface. That's a smooth horizontal surface over which a plank of mass capital M is kept. Fine. Now a man is standing over here, M1 mass, and another man of M2 mass is standing over there, right? Initially the system is at rest, which means each and every part of the system will also be at absolute rest. Fine. Now both start walking over the plank with individual velocities u1 and u2, but both the velocities are with respect to Planck, and both of them start walking simultaneously. Fine, and you need to determine the recoil velocity of the Planck. So recoil means what? In which direction? Left or right? You cannot say that, right? So let us try to analyze the situation first. Right? So let's try to draw a free body diagram of the entire system in reference to the horizontal sense, right? We are not going to denote the vertical forces, not any requirement of that. So let us try to maintain some gap in order to understand the direction of friction force. Why there is a friction force required? It is understood, no? This has to be rough, right? This has to be rough. Then only both men can start walking over it. On a smooth surface, no one can walk. Fine. So if this man wants to move forward with velocity u1, the direction of friction force acting on his feet is this, forward, supporting its direction of motion. Let's call this force as Fr1, this. Then definitely, due to the motion of M1 mass man, the direction of friction force acting on the Planck will be in backward sense, which means towards the left, and it will be same as that of Fr1. Newton's third law. For every action, there is an equal and opposite reaction, and if some friction is applied by the Planck on the man, the same magnitude friction will be applied in the opposite direction by the man on the Planck. Simple. Similarly, if man wants to start walking over this, right, with certain velocity u2, then the direction of friction force acting on his feet must be supporting his motion, Fr2. Let's call it Fr2, and the same friction Fr2 will be acting in the reverse direction, which means the forward direction on this Planck, right? So this Fr1 wishes to move this Planck towards the left, and that Fr2 wishes to move that Planck towards the right. So obviously, in order to determine the recoil velocity, as we don't have any idea regarding the numerical values, we must be assuming certain direction of motion of the Planck, right? So let us say that Fr1 dominates over Fr2. So let us say that the Planck attains a velocity, final velocity v0 towards the left. Fine. And if that is so, can we say here, the first thing which is coming in our mind is the choice of system. So what should be system? System must be M1 plus capital M plus M2. M1 plus capital M plus M2. In that case, the Fr1 and Fr2, the frictional forces, right, those will become internal forces. Internal forces. So, what is the external force acting on the men plus, which means all the three particle system? What is the external force acting on this three particle system? That is equal to 0. That is equal to 0. Which means we can always conserve the momentum of the system. Fine. So if we mention the x-axis, which means the horizontal direction, the momentum of the system in the horizontal direction will remain constant. Anyways, the motion is the individual particle motion as well as the Planck. That is in horizontal sense only. Fine. So can we also write the final momentum of the system in the horizontal direction must be equal to the initial momentum of the system in the horizontal direction. But what is the value of initial momentum of the system? That is nothing but equal to 0. Again, the same logic that initially system is at rest. Fine. Now, while writing the momentum equation, conservation of momentum equation, we need to think about the frame of reference. What should be our frame of reference? So what should be our frame of reference? See, again, it's quite understood now, the same logic, that if recoil is to be determined, what do you think? The recoil velocity is to be determined with respect to what frame of reference? Say, yes, it must be ground frame of reference. Correct? So, let us say that velocity of Planck with respect to ground will be equal to minus v0. Then, can I say the velocity, see we also need individual particle linear momentum with respect to the same frame of reference, that is ground, which means velocity of m1 with respect to ground. By relative velocity, can we write velocity of m1 with respect to Planck plus velocity of Planck with respect to ground? Simple. Now substitute the values according to sign convention. Sir, velocity of m1 with respect to plank. m1 is walking over the plank in the forward direction. With what velocity? u1. But since the direction is forward, we have to take it as positive. So it will be plus u1 plus velocity of plank with respect to ground. Now why there was a negative sign? Because we are assuming that the plank is moving towards the left. So conventionally it is negative sign. So it is minus v0. So we'll get u1 minus v0. Similarly, what is velocity of m2 with respect to ground? Velocity of m2 with respect to ground. Can you write it as velocity of m2 with respect to plank, the relative velocity logic, plus velocity of plank with respect to ground. Move m2 over the plank, move plank over the ground, you will get the velocity of m2 with respect to ground. We have already discussed it number of times, right? So what is the velocity of m2 with respect to plank? Sir, it is u2 but towards the left, which means the negative sense. So we have to write it as minus u2 plus minus v0. So what we are going to get? We're going to get minus u2 minus v0. Right? So can you write? Let's rewrite it. Final momentum of the system in the horizontal direction will be equal to initial momentum of the system in the horizontal direction. Since initially the system was at rest, this is going to be equal to 0. What is this? Can we write it as the momentum statement? m1 into velocity of m1 with respect to ground plus capital M into velocity of plank with respect to ground plus m2 into velocity of m2 with respect to ground. That must be equal to 0. What is our motto? What do we want to determine? Do remember it? We need to determine the velocity, the recoil velocity of the plank, which means we need this value v0. So can you say m1, this we have already obtained it over here, u1 minus v0 plus capital M into minus v0 plus m2 into minus u2 minus v0, that must be equal to 0, which means m1 u1, can I do one thing? Keep all the values including v0 over that side. So m1 u1, here you will get minus m2 u2, that will be equal to, see, minus m1 v0, if you will move it on that side, take v0 as common, minus m1 on that side plus m1, minus capital M on that side plus capital M, minus m2 v0, so v0 common on that side plus m2. Easy. So the value of v0 will be equal to m1 u1 minus m2 u2 over m1 plus capital M plus m2. So what is the velocity of plank with respect to ground? Sir, it is minus v0. See, this is a step, this is the speed. What is the velocity? Minus v0. So you will do negative of it. So negative term will become positive and positive term will become negative over the total mass of the system, m1 plus capital M plus m2. Right? Easy. So again, the same two basic questions, the choice of system, drawing the free body diagram, analyzing it, making the system and considering the system in such a way that all the forces will become internal ones, so that external force is 0, and you can simply conserve the momentum of the system. Other thing is choice of frame of reference. Be consistent, fix your frame of reference while the solution of the entire problem, right? You'll get the result simply. You'll do it. The story is not over yet. Again, can we do this particular problem in 2 steps? Say, while sitting in a competitive examination, definitely we are not going to do this much, which means this problem cannot come into the exam. Is it so? Is that so? No, sir, it can come into the exam, but we are not going to do this problem. Everyone else will be doing the problem like this only. This is the fundamental method. But you know, I always tell you that I am gonna teach you number of analytical tools, the logical reasoning, the analytical part, so that you'll not be needing your pen and paper, right, while solving this particular, even the advanced level problems. So let us try to learn my skill, right? So what is that? Can I erase this part, right? Think deeply. Few minutes back, did I teach you some shortcut trick, right? The generalized part for which type of system? 2-particle system, sir. Can we simply apply that logic over here and solve this problem? Can we do that? No sir, because you only taught us that logic, that shortcut is applicable only for two particle system initially at rest. So is this system initially at rest? Yes sir. Is that a two particle system? No sir. Can we make it a two particle system? Yes sir, we can make it. How? Let's try to see. Again, a shortcut. A generalized part, not a shortcut, again an analytical tool. Can you say, sir, this case that both of them are starting moving like this, M2 and U2. Can I say that this system will be equivalent to, there will be a combined effect of them, right? There will be a combined effect of them. So can I say that this combined effect can be written as summation of two effects? Which means, let us say that at one time M1 is moving with velocity u1 and there will be an effect created on this plank towards the left, right? And M2 is standing. If it is standing, we can consider it to be forming a part of boat itself, plank itself. This, which means now it has been transformed to a two particle system. M1 is one particle and M2 plus M is the other particle. Similarly, the other case, case 2, M1 will be forming a part of plank or boat itself, which means one particle is M1 plus M and the other particle is M2 moving with relative velocity u2, and the reaction of it will be in this particular sense, which means this effect will be provided to the boat towards the right. The boat will be trying to attain a velocity towards the right. So can you say here, let us consider it to be case 1. What will be the value of velocity attained by this plank or boat or this man plus plank stick system towards the left? Can I write it as the mass of the other one, which means M1 into U relative, that is U1 over total mass of the system, which means M1 plus capital M plus M2. Correct? Can I say in this case the velocity attained by this M1 plus capital M plank system towards the right will be given by the mass of the other one, the shortcut part, right? The mass of the other one, M2 into U relative, which means U2 over M1 plus capital M plus M2. Is that easy? Logical? Right? So can you say here, whatever will be the net velocity attained by the plank will be equal to velocity attained by the plank in case 1 vector plus velocity attained by the plank in case 2 vector. Principle of superposition, net effect is summation of individual effects. So we are superimposing two different independent cases in order to get the net effect. So can we write it as with plus minus sign? So conventionally can we write it as minus M1 U1 because towards the left by M1 plus capital M plus M2 plus conventionally can we write it as positive only? So M2 U2 over M1 plus capital M plus M2. Add them up. Denominator is same. Are we going to get M2 U2 minus M1 U1 over total mass of the system M1 plus capital M plus M2? The same result like this. Understood? No? Can we do it like that? Easy. So what we are going to say that definitely all the advanced level problems can also be done in 2 or 3 simple fundamental steps. The only requirement is we must be having a very strong logical and analytical ability. And I'm going to teach you that, right? We are going to learn it together. Is that easy? So pause the video, try to do it on your own and try to do this generalized part as well on your own. If you're having any doubts, you can simply review it again, right? That's a smooth horizontal surface. And on this smooth horizontal surface, there is a wedge of mass m kept initially at rest. And the contact surface of or the surface of inclined is also smooth, right? And you are taking a block of mass m naught and moving with velocity v naught towards the wedge or towards the inclined plane. And the problem is you need to find the velocity, attained, you need to determine the maximum height. You need to find the maximum height attained by the block over the incline. So initially the block will be moving faster, it will strike the inclined. Since there is no opposition, the incline will also be moving forward. But since the block will be moving faster initially, so it will try to move upward the incline. And after some time, when the incline will become faster and the block will become slower, the block is going to move down the incline. So you need to determine the maximum height, find the maximum height attained by the block over the wedge. Over the wedge or over the inclined. So that's what the problem is. Fine. So now how we are going to solve this problem? The first thing, see, what is the condition for maximum height? The condition for maximum height is the block must go rise, 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 and ultimately it should stop. So what is the condition? The condition for maximum height is block must stop. But the block must not be stopping absolutely. Rather, it should be stopped with respect to its platform, which means block must stop with respect to inclined or with respect to wedge. That is the most important logic of this particular problem. See, it's quite simple. That, see, if the wedge is like this and the block is like this, so initially only block will be moving, so it will go and go and go and strike the wedge. The wedge will also start moving. Till the time block is moving faster, it will keep on rising, right? And after some time, when wedge will become faster, the block will start moving downwards. So there will be a stage attained when neither the block will be faster than the wedge and nor the wedge will be faster than the block. In that case only, the both objects will momentarily be moving with the same particular velocity, and that will be the only condition when the maximum height will be attained. Because when block is faster, it will keep on rising. When wedge is faster, the block will be moving downwards. So when is that situation when the block is going to attain the maximum height? The situation is that both will be moving with a particular velocity only, or in other words, the velocity of block with respect to plank must be equal to 0. So block must stop with respect to wedge or inclined. That is, you will say that velocity of block with respect to plank, velocity of block, I'll write it completely, velocity of block with respect to plank must be equal to, with respect to wedge must be equal to 0, right? And in that case, can you write velocity of block with respect to ground minus velocity of wedge with respect to ground? That will be equal to 0. It simply means that velocity of block with respect to ground will be equal to velocity of wedge with respect to ground at maximum height, and both will be sticking together and moving in the forward sense, which means since both of them will be moving with a common velocity, let's name it V common, and since it is in forward direction, let's write it as plus V common. Plus V common. Is that understood? Right? So can I say here, my system must be block m0 plus wedge of mass capital M. So why the wedge starts moving? Because when the block strikes the wedge, there is some normal reaction or a reaction force offered by the block on the wedge, and the same will be offered by the wedge on the block. Newton's third law, right? So what you can write, that normal reaction N or R will become, if we take this as a system, normal reaction N or R will become an internal force. And if that is so, this implies will be the external force acting on the system, dear. The external force, I'm writing it again and again so that you will also have a clear-cut idea of it, right? The external force acting on it is 0, which means the system's linear momentum can be conserved, which means final momentum of the system in horizontal direction must be equal to initial momentum of the system in the horizontal direction, right? Now let us try to analyze the situation. What is happening over here? Initially, the block, the wedge, capital M, was at rest, and the block M0 is moving with a velocity V0, right? That is mentioned in the problem. Finally, what is happening is both are moving, M and M0 somewhere over here, both are moving with velocity V common when the maximum height H max is attained by the block. So both will be moving together like this with velocity V common, right? So can we write this implies the initial momentum of the system, which means M0 plus V0 plus capital M into 0. The initial momentum, fine, that must be equal to the final momentum M0 plus capital M into plus V common. Easy. So M0 V0 will be equal to M0 plus capital M into V common. Can we say that V common will be equal to M0 V0 over M0 plus capital M. M0 V0 over M0 plus capital M. We can do it like that. Also, can we say that during the entire process, was there any heat dissipation? Is there any friction or so? No dissipative force, right? Which means the entire total mechanical energy of the system is going to be conserved. Which means there will be loss in one form of energy and there will be gain in the other form of energy. So can you say that there is some gain in the GPE, the gravitational potential energy, because one of the object is going to be elevated, right? Height is getting attained. So which means there will be an increment in GPE. So definitely the other form of mechanical energy, that is the kinetic energy, is going to be lost, right? So can you say it is going to be decreased? So we will say loss in kinetic energy must be equal to gain in GPE, gravitational potential energy. Loss in kinetic energy must be equal to gain in GPE. So can you say what is loss, sir? Loss is always initial minus final, kinetic energy initial minus kinetic energy final, and gain is always final minus initial. So GPE final minus GPE initial. I have already told you a number of times that potential energy is a relative term. So while writing the expression of GPE, any type of potential energy rather, we must be needing a reference. Fine. So taking ground as a reference, can we say that initially everything was at ground only? So what is the initial gravitational potential energy? 0. So will we get kinetic energy initial minus kinetic energy final will be equal to GPE final. The gravitational potential energy is gained or enhanced or attained by only this block, not by the wedge. What is the initial kinetic energy? Sir, initial kinetic energy only block was moving, no? So half M0 V0 square. Half M0 V0 square. What is the final kinetic energy? Sir, block plus wedge will stick together and they will be moving with V common square like this, and that will be equal to GPE final. What part is attaining GPE? Only the block, which means M0 G H max. But we know that V common we got the value of V common, right, by applying the conservation of momentum. What is that? That is M0 V0 over M0 plus capital M. So if we try to substitute this value of V common over here, won't we get the value of H max? We'll get it, right? So I'll do it for you. There's a lack of space over the board. Can I erase this part? I hope that is understood, right? Right. So I'm also erasing this part because the value I have already, I can see the value over there. So can we say that, substitute it? So half M0 V0 square minus half M0 plus capital M, and you can write it as M0 V0 over M0 plus capital M the square, and you will get M0 G H max. Correct? So take this half value as common, or you can write it as M0 G H max and take this half common. So you will get over here, first term m naught v naught square. I'm just writing LHS on RHS and RHS on LHS, not a big deal. Minus, half is already taken as common. You will get m naught square v naught square. In denominator, you will get m naught plus capital M whole square. But 1 power is also over there, right? So 1 power will get cancelled, and in denominator, only 1 power will be remaining. So you will get m naught square v naught square by m naught plus capital M single remaining power, right? So m naught g h max, try to solve it, half, take LCM. So m naught square v naught square plus m naught capital M v naught square minus this term m naught square v naught square, and in denominator you will get m naught plus capital M. So you'll get these two terms cancelled. So remaining m naught and m naught will also get cancelled. So h max will be equal to, you will get m v naught square by m v naught square, the remaining term, divided 2g m naught plus capital M. M naught plus capital M. In this way, you can easily determine, by using the conservation of momentum and conservation of mechanical energy, you can easily determine the maximum height attained by the block over the wedge. Hope that is understood, right? What do you say? The story is completed? Not yet completed, right? So, sir will definitely be teaching you how to solve this big problem in 2 or 3 steps, right? But before that, let us try to recollect one more logic which I taught you while teaching you the center of mass frame of reference, right? Center of mass frame of reference. Can I erase all this? The problem, I'll leave it over here so that you can compare the methods. Fine. So this was our way 1 of doing this problem, right? But any good problem, any advanced level problem can be done by number of good methods as well, right? So see over here, way 2, and I'll just try to make you recall that problem, right? Recall that logic. Do you remember I told you for 2 particle system, again for 2 particle system, we can see this is also a 2 particle system. No, for 2 particle system, there is another way of writing the kinetic energy of 2 particle system. And what is that? The way is kinetic energy of center of mass plus half mu v relative square, half mu v relative square, which means, what is that mu over here? That mu is reduced mass. Reduced mass, that is product of masses over summation of masses, m1 m2 over m1 plus m2, correct? Right? Now can you write here in this particular problem, the total mechanical energy initial must be equal to total mechanical energy finally, since there are no dissipative forces inside the system. And if that is so, can you write kinetic energy initial plus gravitational potential energy initial, that is to be equal to kinetic energy final plus gravitational potential energy final. Mind it, potential energy is a relative term. So for writing the values and expressions of potential energy, any kind of potential energy, we must be needing a reference, right? So let us consider a reference to be the ground, and let us say that at the ground, the gravitational potential energy is 0. So what is the value of GP initial? 0, since both the block and the wedge both were at ground only. So can I write KE initial as kinetic energy of center of mass initial plus half mu v relative initial relative velocity square will be equal to kinetic energy of center of mass final plus half mu v relative final relative velocity square plus finally only the block is attaining GP, right? So m naught g h max, m naught g h max. See, we are going to solve this particular problem in 2 or 3 steps only. This was only the recollect part. We were trying to recall it, right? So another way of doing it. Can I say, since there is no external force acting on the system as such except gravity, right? Gravitational force. But sir, we need not to encounter the work done by gravitational force since that has been already encountered in the change in GPE. I'll repeat the statement again. Whenever there are no external forces except the gravitational force, then you can simply ignore the work done by gravitational force while writing the mechanical energy conservation statement, because whatever will be the work done by the gravitational force, that has already been encountered in change in GPE of the system, which means you need not to consider any change in kinetic energy of center of mass. So this will get cancelled. Logical? Remember? Right. Also, what is the final relative velocity? Sir, finally both will be sticking together and moving with the same particular velocity. So the final relative velocity will be equal to 0. So let us substitute half. What is reduced mass? M naught capital M over M naught plus capital M. Initial relative velocity V naught square, that will be equal to here M naught G H max. See the result, M naught will get cancelled and you will get the result of H max as M V naught square over 2G, this G will come over here, M naught plus capital M. Easy, very easy, no? So you need not to conserve the momentum separately and then conserve the energy separately. You can simply apply the logic like this, right? That the kinetic energy of center of mass will get cancelled. I'm not telling that they are zero individually. I'm just saying that whatever will be the value, that is going to be the same, right? Got the point? Right. Another method, shorter, right? Now, this method is based on that fact that, one situation can be simply related to another situation, and in the actual competitive exam, say it engineering, say it medical, this ability is also checked, that whether you can relate the newly presented scenario to the previous learnt one, right? So, way 3. Finally, both will stick together and keep moving. Finally, both will be sticking together and moving with the same particular velocity. Have you heard this somewhere else? Any type of collision? Yes. We have learnt it in perfectly inelastic collision. That finally after the collision, both the objects will be sticking together and move with the same particular velocity. And in that case, there is some loss, a huge loss in initial kinetic energy of the system. And we also derive the expression for it, right? Remember that in case of perfectly inelastic collision, the loss in kinetic energy will be given by half mu into V relative square. No? So, go to the topic of collisions first, review it, and then come once again. So, I'll be teaching you the third method. So, hope that you have looked into it. So, can I say, since both will be sticking together, it is a type of perfectly inelastic collision. Perfectly inelastic collision for a moment. And that moment only we are interested in for maximum height, for H to be maximum. It is not a type of perfectly inelastic collision as such, because the block is not going to be stick to the wedge at the maximum height and remaining at that level only. It is going to slide down further, right? But at that moment when we will be calculating or needing the maximum height, that moment the system is going to behave as perfectly inelastic interaction, which means up to that moment, can we say loss in kinetic energy will be equal to half mu V relative square. This is the expression. In schools as well, we derive this, that's a standard derivation, we derive this statement. So can I say if one form of energy is getting lost, loss in kinetic energy, the other will be gained. So which energy is gained? GP. This implies, can I write this loss in kinetic energy as gain in GP? Yes sir, you can write it, that gain in GP will be equal to half the value of mu M naught M over M naught plus capital M and initial relative velocity V naught and its square. So can I say gain in GP? Gain is final minus initial, only the block is gaining the potential energy, the gravitational potential energy. So its mass M naught G H max will be equal to half M naught capital M over M naught plus capital M, and it is V naught square. You can see M naught will get cancelled out. So the shortest method, H max will be equal to mv naught square by 2g, and it is m naught plus capital M, m naught plus capital M, the same result. So for a particular problem, undoubtedly that was a very good problem, and we can see number of methods are there, right? So hopefully you got the logic, both the logic, the choice of system as well as the consistency of frame of reference, and we'll keep these two things in our mind, and definitely in near future we are going to practice some more problems, and the rest of the things, which means your doubts and all the previous year problem, we are definitely going to take care of it in the live sessions. Till then, all the best. Thank you.